Been called out today to have a look at this control panel. Now what it does, you've got an intake fan up here and you've got an extractor fan up here, and then you've got all your gas appliance, or you've got your gas cooker there. And basically what you have to have is the intake has to be working as well as the extractor working, and then that'll open the gas valve, which I'm not sure where that is, but then that obviously supplies the cooker, so then you can use that. And so basically this is what we have here. Now I did pop over and have a look last week, and they had someone else out who had said it's the contactor that's gone wrong, so they don't really work with, so I got called out. When I came and looked at the contactor this morning, I do keep a few of these on me, and amazingly I did have the correct one. So as you look at the contacts there, you can see the top of it has burnt out. When I did initially try this, and I just manually overrode the contactor by pushing it in like this, the fan did come on. In fact, I can show you that with the new one. So I'll turn this on. So when I just physically push that in, it brought the fan on. Now you might not be able to hear it, but it is now working. So that showed that the contactor is working. I'll just stop that. So this is the new contactor that I've put on. It's a very similar spec. Got it working. However, after a little bit of investigation, I then turned the switch on, which was this switch here, and that wasn't doing anything. These switch controls are normally just in parallel with number 13 and 14, parallel with the locking contacts, number 13 and 14. I checked to check that there was a live input, which comes directly from this one here, which it was live. Then when I pressed the button, it was clicking, it was making all the right noises, but it wasn't actually engaging with the secondary contact here. So basically it wasn't going from there through to here, and I couldn't work out why it was. So anyway, I've took it off, and as you can see, the bottom of it is broken. And then if you just look through there in the switch itself is the little green bit that's broken off. So all I'm going to do is just swap the contacts over to this pair of contacts on this side. So I'll just take them from this side onto this side, which should work, and that should be okay. And so just to check that that is okay, I'll turn it on. Obviously this is live, so we have to be a bit more careful, but if I just push that in there like that, that's brought the contactor in. It's now, it's like I said before, it's in parallel with 13 and 14. Now you can hear the fan going. Just while I'm here, just to be safe, I'll turn this off again. I'd just like to maybe go through a couple of the other controls here. So as you can see, we've got the supply start, we've got the what else we've got the run, so that's just a light that comes on in parallel with the fan to tell you that it's running. We've got the stop button, which is in series with the circuit, so again that's in series with these connections here, 95 and 96, and it's in series with those two and A1 and A2 of the coil. It's in series with 95, 96, and also in series with the coil A1 and A2. Again, with it says on here, it says normally closed. So what that means is the contacts between these two terminals here, it's a closed contact, and so normally there's continuity going through these two, and so then that just goes and the stop button is in series with these two, which then go through to A1 of the coil. However, just we've also got 97, 98. Now quite often these aren't used, I'll just explain those in a second, but with 95 and 96 normally closed, that's the thermal overload cutout, and that's all to do with how much current is going through this thermal cutout. And if, for example, if too much current is going through, or this setting here is not set correctly, these normally closed terminals will turn to a normally open terminal, and that will, because the coil circuit is in series with these two, if that opens, that will break the circuit and it will de-energize everything and turn off. However, when the thermal overload is operated, these go from a normally closed to an open contact. 97 and 98 go from a normally open to a normally closed. And I can't quite see exactly how this is, but what I'm thinking here, we've got a live connection, a permanent live connection at the top, and then we've got a permanent live connection probably at the bottom here, well we have, and then what this one then does, this then goes through and it brings this light on here. And so basically, if it trips because there's too much current or a fault, these go from a normally closed to a normally open, these go from a normally open to a normally closed, which then energizes this fan here. So you know that there's a problem with the setup, basically, that too much current is being used. Now that's possibly just because this hasn't been set correctly, or it could be another problem.